Hey everybody, I'm Glenn and this is Fun King 3D. Xander, we're doing a hotbox video.
Oh, I thought you told me we were gonna do a Raspberry Pi video.
No, this isn't the Raspberry Pi video, this is the hotbox.
Oh.
Hotbox version 3. Final assembly and final thoughts. Stick with us. Alright, so if you've been following along with the Hotbox series, this whole thing started because we needed some way to control the different camera angles with our OBS software without having to fumble around with a regular keyboard. I looked into small programmable keyboards and they were ridiculous in price, and I thought, you know, we're makers, we're smart, there's got to be a way to do it, and we did it. So if you've been watching the series, you've seen up to somewhere in version 2. And I'm going to be totally honest with you, the videos are a little bit jumbled and some things didn't get recorded the way they should have. There was some camera issues. There was no assembly for version 2. So there is assembly for version 3, and we're going to show that to you right now. Follow along with that, and then we'll catch up with you right after that. All right, so when I assembled the Hotbox project originally, I didn't make a video of it, and I kind of felt bad for not. I brushed it off as being pretty easy, but I don't know, there are steps to it, so I thought I would go ahead and do a build video portion anyway for the Hotbox version. It's actually version 3 or revision 3. Here's the PC board. I completed drilling it today. These are the drill bits that I ordered through Amazon. They're a 0.8 millimeter, and you get a 10 pack, and they weren't very expensive. I can't remember how much, $5 or $6. But I will have a link in the description to those. Originally, I had bought this pack, same brand, and it was 10 different sizes. It was looks like 0.3, 0.4, 0.5, all the way up through 1.2. So 0.3 to 1.2. And I initially took out the 0.8 and broke it. They're really fragile. And I use this very antique hand drill. It wasn't made for the 1/8 inch shank bits, but what I did was I used a collet out of a Dremel, and I lock the bit in there, and I use a shim. I don't know what I did with it. Oh, here. These are shims that they sell at the hardware store for when you're hanging a door or whatever, when you gotta shim something, when you gotta, you know, level it out or whatever. So I use this, and I actually put the board on top of that, so when I drill through, it catches into the gaps of this, and it helps to not break the drill bits. Your mileage may vary. Hand drills, newer than this one with the actual, you know, thumb spinner and stuff still on it, about $10 through Amazon. I don't necessarily have any recommendation on that. It's up to you. A few other things I got for this project was a bag of these push buttons. They're 90 degree. They're long button. I didn't get the long button intentionally. I bought them because the bag was priced right, and they were 90 degree, and apparently 90 degrees is a little bit harder to find than the flat ones. But I will have a link to these in the description as well. Let's see, what else did I get? Oh, I ordered in some new female headers. If you watched the other Hotbox project videos, there was an issue. Adjust that focus just a little bit. I move the camera further away. There we go. Autofocus is terrible at this close range. But if you watch the rest of the Hotbox videos, I had problems with the female headers. They just didn't solder well. So I ordered a different brand. I don't know how these are going to solder. We're going to find out together. If they solder well, there will be a link in the description. Don't solder well, well, there'll be a link in the description under the Do Not Buy section. And then here's Hotbox version 2. And again, the only thing that really changed on this version was the fact that I used, it's just a different board layout. The original Hotbox board, I had the resistor packs outside, and the new one I moved them inside just to have a little bit more real estate. Really, I just more real estate for the Fun King guy, but no, not really. I wanted to have good mounting pads. The mounting pads on the first one was really tiny, and the mounting pads on the new revisions are better. Revision 3 came about because I wanted, well, I had to have connections for a switch. We'll get to that in a second. And I also put a reset button on here, which is what the little 90-degree button is. Because the Arduino Pro Micro has no reset button built into it. And sometimes during programming you need to reset it. So I did go ahead and throw a button on there. Again, if you don't get the long shanked one, if you get the little short one, that's alright, because you'd be able to poke it with a pen tip or whatever. So let's talk about the reason for revision 3. I introduced to you the Hotbox not in the cardboard box. This is a 100% custom designed and printed enclosure. It's printed on our ANET 8. We added this rotary switch right here, which gives you 4 positions. You got position 1, position 2, 3, and 4. And what that button does is each time that you click it in, it's a completely different keyboard. So in my position 1, it's set up for OBS, which is our streaming software. It changes the camera settings, which is just like it did before when it was in the cardboard box. My revision 2 currently is just set to open a bunch of web pages. But you could have that set for, say, Fusion 360, or I use it for Rhino 3D. I don't know, running cheat codes on a game if you want to. It's whatever you want to make it. Shortcuts for Photoshop. Just shortcuts that you run all the time. You can set this thing to open programs. You can program each of these buttons like crazy macros. So it's, I know I designed it and I'm a little bit biased, but I'm in love with this project. I told my wife last night, other than my 2 children, this box right here may be the greatest thing I've ever made. And I've made a lot of stuff. I made the house we live in. So here's a little peek at the back. I did emboss the Fun King 3D hot box into the back of it. If I choose to release the STL files on this, I will also release a version that doesn't have that. So you don't have to have Fun King embossed on your hot box, but the back of this is held together with very small metric screws. They're like an M2 screw, but back just pops off. Here you have the mounting point for the board, and the USB and reset switch slide right through that hole. And here you have the mass of wires. And we're going to get to that. We're going to get to that in a few minutes. The only thing that I don't have for tonight's little video is I don't have the screws to hold the board into the box. Haven't experimented with that yet, but by the time you watch this video, we will know what screws go in there, and that information will be in the description. That way you get a little reading with a little watching. See, it's a 2-for-1. And yes, you are only looking at my hands tonight. I don't. I normally have my picture up here in the corner, but being the positioning that I have this camera, it's right smack in front of my face, and the other camera would be looking at the back of this camera, so that's not fun. So without further ado, I say that we build Hotbox version 3. Here's here's the breadboard. And this time when I prototyped it out, I did actually, you can't really see. I'm going to go ahead and start pulling some of these wires out of the way because we don't really need those in there. The resistor packs are here. They're actually in the board right next to the Pro Micro. And I will put the Pro Micro and all of that back in the description, just like before, so that you don't have to go hunting to the old videos to go and get one. So because of the way this was laid out, one of the resistor packs are here and one of the resistor packs are here, but that doesn't really matter. Very gentle when prying these out because, like I said, I did it before with the USB in there and ripped the USB slot right off of there. And then we're going to take this out. I'm going to take this out. Now these resistor packs came from that same kit that I bought when I built version 2. And again, I'll put those links down in the description. It was a nice little pack. They're 10K, 8 resistors, so 9 pin. These guys here, you do have to cut them, so we're going to snip these. We gotta have 12. So 1, 5. In fact, you know what? I'm going to cheat. Take the Arduino and set it in there. I'm going to take my little side cutters. If you don't own a pair of these, go get some. The one's from Harbor Freight. All right, so you see that these, I don't know if you can see that. It's a pretty gnarly little edge. You do lose one female every time you cut it, but it was way cheaper to buy them in 40 pin lengths than it is to buy them already cut in 12 lengths. And generally the 12 pin lengths come, that shot clean across the room. The 12 pin ones come with really long pins for plugging into another Arduino. They're used for going through a shield. All right, so once I cut those, I like to take a little sanding paper. You know, I knew I'd finally have a video where people were watching me sand something. This is like a Bakelite type material. I mean, it's probably a plastic. I don't think they actually use Bakelite anymore, but it sands down pretty good and pretty fast, so you don't have to use a lot of pressure. I don't know if you can hear the printer running in the background, but I'm printing a rubber band gun for Xander. He doesn't know it. He probably thinks I'm just printing it to shoot him, but I'm actually printing it for him. Alright, so that makes a pretty clean end. And you can clean it up as much or as little as you want. That's up to you. Nobody's ever going to see it, but I do take a little pride in my stuff, so. Alright, so now I hand drilled all of these holes, like I said in the beginning. So the holes aren't necessarily perfectly straight, but most of the holes I drilled at the minimal size. So if I do have to enlarge them, get it in there, which that's our fingers crossed, the rest of them go like that. You don't want to force it because you will jam that copper right out of there. Give it a little wiggle. It should pop right in. Now with these guys, with nothing else on the board, I mean the switch clears. Angle on that, switch clears, but you can actually put it down on your desk. Just don't push down on those pins because you're pushing them into your finger. But you can put it down on a flat surface and push it, and then you know you got it all the way in. All right, the last board, revision 2, that back. See, I have some nice printing on the top, and I did that the same way. It's just toner transfer with an iron. And I'm not going to describe that again. It is in one of the last Hotbox videos on how I do it, just using laser photo paper from Staples and iron, and all 200 pounds of me pushing on it. But I didn't do transfer on top of this one, really just because I was more excited about putting it together. And I know the way that the components go in, so this is kind of important. The resistor packs, and I'm not going to be able to, well, maybe I will. Let's bring this way in. I'm going to crank that focus. All right, you see the second pin in there. It's to the side of the A. You got that A, but next to the A, there's a dot. That dot is your orientation dot. Oh, there, that's beautiful focus. All right, that dot needs to go towards where the USB port is on the Arduino, sorry, on the Pro Micro. And that's both of them. Both of them go in that same way. So making sure that that dot is towards the switch and towards where the USB port is. And I probably should have put these in before I put the headers in for Pro Micro. That's okay. I'll take these little tweezers. When you do this at home, you might want to put these in before you put the headers in. And in it goes. All right, same thing now. The dot, my dot's on this side. I need to make sure that that faces up the same direction. Yeah, please put these in before you put the female headers in. And in it goes. Just like that. Right, now what I did not get out was the male headers. So I'm going to leave you to stare at this board for just a second here as I dig out some male headers. Around here somewhere. I have a large roll-around toolbox I got from Harbor Freight that I use for doing this. Alright, so, if I'm not mistaken, it's 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So, the way these work, these actually have a little score line in between. So you go 1, 2, 3, 4, 5, 6, 7, 8. And then before I snip it, like I get into position, I like to double count. 1, 2, 3, 4, 5, 6, 7, 8. And snip. Now we have an 8-pin header for here. Now these pins are a little bit large. They don't always go into the holes real easy. Again, hand drilling, the holes aren't perfectly straight. So you may have to, I may have to drill these holes a little larger. Go to the next size up in bits. Because if you force these in too hard, I mean you can't really push on the pin, it'll go into your thumb. But like if you push against this black part, you'll push it right off of the pins. So nobody wants that. I was trying to keep everything with the smallest size hole possible so that we had the most amount of copper on the backside to solder to. And these pins on these headers are fatter than all the other components. I definitely lost a. Let's take a second here and get these soldered all in. And we're going to worry about these pin headers. You guys see that? You know, it's kind of far away, but if I move the camera in too far, it'll just be my hands will be all that you see. All right, so I have my handy dandy soldering tip cleaner here. And I plugged the gun in and turned it on before I started tonight, so it should already be good and burning hot. Get that into view. Oh yeah, plenty of heat. By that view. I'm going to move my tip cleaner up here. It'll be out of view, but I don't think you guys need to see me cleaning the tip of the soldering iron. So I like to make solder or to make PC boards at home and stuff. I think it's really cool that it can be done. But something that I really want to work on is being able to do like my own printing, you know, like printing the other side better and doing solder masks so that it makes the soldering a lot easier. But of course, having PC boards made, I mean, once the oh, that was almost bad. Once the design is done and if you can, you know, if you send it out, it's getting so cheap now to have boards made. An ad came across my YouTube or my Facebook. 3 boards for $3. As low as $3. But this little board would have fallen under their categories for. All right, this guy's going to be a pain. But for the $3 board, it would have met the requirements. So, and if this particular project happens to get popular enough, not that I necessarily think it will, but if there was enough interest, I would be willing to have some boards made professionally and even put together a kit, put together all the pieces into a, you know, just into a Ziploc baggie or whatever, and sell them out to you guys for cost. Not looking to make a buck, just looking to put that utility out there to everybody. And again, I know I built it, so I'm a little biased, but I'm absolutely in love with this project. So this is just such an easy, there's just no components to this. So, but now it's going to be a matter of getting these headers into the, sorry if that was loud. 1, 2, 3, 4, 5, 6, 7, and 8. Crossed, and one more time. 1, 2, 3, 4, 5, 6, 7, 8. And then this should be 12, I think. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. And you know what? We're going to have a problem. I'm going to admit this right here on live stream. I did not include an additional pin for the switch, for the rotary switch. So what I am going to do, I will update all of these files before I upload them. but you're going to get to watch me drill another hole because we need to have 13 pins across there, 12 for the, and I could get by with this and just not use the 2 other ones, but I might as well fix it now. So what I need to do then is determine those 12 are coming across like this, and all I'm going to do is jump the solder across. That's so tight, so tight. All right, let's see. Sometimes stuff like this happens and you got to work through it. Again, okay, that Pro Micro is plenty far forward on the board, so I'm actually going to put that other pin in front of. I will put it all by itself. I'm hoping you just get to watch me drill a hole and not watch me break a bit. Can you see? I got to kind of hold my hand like this because I got to hold the board down at the same time. And these pins are pressing right into my hand. All right, it's through. You got to be so careful as not to tweak this because you'll snap these bits off like they're nothing. All right, so we're going to do a hot fix on this. And again, I promise you that when I release the files, that they will be correct for 13 pins, not 12. But in the meantime, I need 12. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. One more time. 3, 6, 9, 10, 11, and 12. And then we'll cut a single. See if I have any chance of getting these in there. No, I'm afraid that every one of these holes are going to have to be drilled larger. And then we have to have a single pin, and that'll be the single pin input for the rotary switch. Not that it matters because it's going to the same thing. It's got a 5-volt supply on it. Oh yeah, that one fits. All right, now that I have that in there, before I solder it, I'm going to lay the Pro Micro back in there, and then you can see it clears plenty fine. So I will go ahead and live with that, live with my mistake right here live on the air. And you can all laugh at me all that you want. I am human, mistakes happen, but I'm a maker and I can figure out how to get around it. All right, I'm gonna grab my pliers because I really think that these will fit. I think they just need to be manipulated. It's always hard to know what tools to bring to the table with you. And usually I bring everything and then I have a huge mess to clean up after I'm done porting. And all I'm doing, I'm just grabbing the pins with my bent nose pliers here, and I'm giving it a little twist back and forth. I'm doing this, but very little, just to try to get them all into the holes. And they're so close, so close. Remember what I said to you, you don't want to push down on the plastic, because if you push down on that plastic, you'll just push it right off of the pins. Definitely want to just manipulate the pins. Oh, I feel one of them coming through. All right, so here you go. See what happened? See that pin? Oh, that pin? Oh, it's shorter. I ended up pushing the pin down in. but it's okay because you can move the plastic afterwards. You just want to make sure that you don't push it too far and get them all out of whack. And I think that I may have to do that across the board. May have to push them in one at a time. This makes me a little less sorry that I didn't show you guys the first building. I guess the lesson here is drilling your holes is important. All right, so those first 4 are in. 5th one's in. 6th one is in. And I just bent the 7th one. So that's all right. Straighten it right back out. I'm not squeezing real hard on these, just a little bit and giving them a little wiggle. All right, so there they are coming through. Now I want to make sure that they're relatively even. I'm just trying to pull that plastic down against the board, just forcing the pins through even more. All right, so that plastic's now down. Pins are too far, so we're going to actually squeeze between the plastic and the pin itself. We're going to push those pins back up. I would suggest going to, these are all 0.8 holes, which is your most common component size. I would go to like probably a 1.0 on these. In fact, I might go ahead. My 1.0 isn't one of the ones I broke. We'll very quickly punch these holes up in size. Because they're kind of wonky. It's all right. I'm going to go ahead and solder these in and try to get a little jump over to that other pin. If you guys can see that, but I got the pin good and hot and got it wet, and then got this wet and joined the two and let them combine. So you will see Hotbox board revision 3B. It's just fun to push the reset button. All right, so let me see what I have drill bit wise. And this container was not marked, so I Sharpied it. My 1.0 is actually good. We're going to change out, put away the 0.8. Yeah, this multi-set, this 10-pack of the multiple ones, the 0.9 was already broken when I got it. It was broken inside the casing, and I contacted Amazon for a return, and they had no problem. They were going to take it back. And then shortly thereafter, I broke the 0.8, and so I couldn't morally justify sending it back, being I broke the other one. So I ate the $5 or whatever it was. And then I ordered this nice set of 0.8s. Didn't realize it was the same manufacturer. I didn't put anything underneath there because the board, the board has feet now. So it's not gonna hit my table. Plus I'm not really drilling, I'm just boring the holes open. And there it is. That's the whole board soldered. So that's what you missed the first go round. That's the whole thing. And when you put the chip in, now it's built. So I'm really bummed that I didn't figure the whole screws out beforehand. I could use these ones, but they'll go all the way through. These are 5mm blocks on a 3mm chassis, but I'm afraid that if I screwed that in there, it would go all the way through and out the bottom, and we don't want that. So, but there you see, got a nice little USB port in there, got the reset button. I'm very pleased. I did have to run a couple of tests, and they'll be included in the STLs if I release this. One of the STLs is just this piece right here, so that you can print and make sure that your board fits. I also did these. This first one was a failure. The hole was too tight for the button, so I had to increase it by about 0.5 millimeter, and then I tapered it. The holes, this is the outside surface, and the holes are tapered in like this, and the switches slide right in. You know, they have those little locking tabs. You see the little tabs, and they're great. They're absolutely perfect. So now you guys can label your buttons however you want. You can skip the labeling. It's up to you. I won't come to your house and be angry about it. Again, for those who missed it, I did mine 1, 2, 3, 4 this way because I use this mainly for changing the scenes in OBS. And 1 is my main screen, and 2 is my main screen with the detail camera, which is what we're looking at now. And then 3 is the detail camera, and 4 is the detail camera with me in the scene. 5 is the overhead shot. 6 is the overhead shot with me in the scene. 7 is the screen, so that I can show you software and whatever I'm working on. And 8 right now has no designation. So, and then mute. Mute's pretty obvious. And this is my record button. This starts and stops the recording. And obviously we're not using it right now because it's all gutted. So if you guys want to bear with me, I'm going to go ahead and wire this up, and I'll kind of talk as we go through it. If not, you can skip forward or skip, whatever. Run to the end. Go to the store and start buying stuff to build your own one of these, or whatever it is you want to do. So this hookup was pretty straightforward. I'll have the link to this rotary switch in the description. It actually has a washer underneath here that allows you to set it to be a 1 position, 2 position, 3 position, 4, up to 12, I think it is. Yeah, and you guys won't be able to see, but there's actually designations next to the pin 1 through 12. But I only I only wanted 4 because I was out of inputs. I used the 3 analog inputs and converted them over to digital to be my inputs for these. Color coding is up to you. If you buy the ribbon cables that I did, this is the colors that come with it. So, but red is my input, and then I had actually written around the edge of here from pin 1. So it's blue, purple, green, gray is the way that those go. And those, the red is going to go into this now single header that we built. And then it's going to take me a minute to think about this. A0, we got 10, 16, 14, 15, and A0. So A0 is the 4th pin down on the passenger side. Unless you're in the UK, then I guess it's your driver's side. And then we're going to go to purple, green, and gray. Now, I did not, I could have gone with like a 4-pin header on here, which would have been fine, but being these cables that I bought, these cables already made up, I just left it alone. But you can see I soldered the wire to the pins, and then put a little heat shrink on it, and then I put a larger piece of heat shrink over just to keep the strain off of the small wires. All right, so it's going to be a little bit challenging because I have to think about where I programmed each of these buttons to be. And when I originally hooked this up, they were consecutive, like 1, 2, 3, 4, 5, 6, 7, 8, and then I moved them around once I put them in the cardboard box. So the mute. All right, my black wires go down here. Go down onto that 12-pin header. Then this first one is going to be this first one. Again, black to the 12 pin, white to number 2. And I'll have to go back and test all of this afterwards, and if it doesn't work out, sorry, I had to mute my phone. All right, so now this is button 1, which used to be button 3. All right, so, and again, color choices are up to you. I always go with whatever the darker the 2 is to be the common, which in this case is a hot common, but all right, so, oh, I'm sorry, that's button 7. We gotta undo that. We want to go down here. So black to the common, white to number 3. I'll probably have to change the programming on this. Because by color, when I soldered the wires in, like this would have been the second button, but then I made it number 3. So I'm going to go ahead and continue on with the way it was originally. And if I have to change it, I will. I'm going to go to here, and orange is going to be the common. And as far as cable management goes, I mean, you can handle it however you want. I generally just bunch it up and put a zip tie on it. I don't want the wires to be shorter because I want to be able to take the back cover off. But if you want to braid them or whatever you want to do. All right, I'm going to go down here, and that orange is going to the bottom. Because I was actually doing a video on this, and I had opened the cardboard box, the temporary enclosure, and it unplugged one of my buttons And so then all of a sudden that camera didn't work. I won't tell you what video it is, you have to find it. But it's there. Again, I don't hide my mistakes. I'm human just like everybody else. And all right, so I think blue is a little darker than green. Around now, this one, so when we get to the other side, it goes to the bottom. Goes to the bottommost pin, and those are you can designate those in the software. The other 2 pins that are in there are for 2 additional buttons. You can actually have up to 12 buttons, and I did that because I want to add a foot switch. And just so you'll know, my gabbing is what caused the switch, because I said, you never know, maybe you can put a switch on there and make it into multiple keyboards. And that haunted me, and I thought about it, and thought about it, and thought about it, and figured out how to do it. So, and the crazy part was I ordered all the pieces to do it before I actually knew it was going to work. So I took a chance, but it was okay. All right, so now what I'm going to do is I'm trying not to burn myself on my soldering iron. Let's get the hot stuff out of the way. I'm going to grab a USB cable from over here. I'm going to kind of just, oh, you know what? I need to put a zip tie on there. Let's put a zip tie on there. Whole bag of those right here. Alright, so we're going to come up underneath this. Just going to wrap right around the wires. And we're going to take our flush cutters. Snip that off. Now you can put a second one up further if you want to. I don't really think it's necessary. But we're going to get this lined up in the hole, and I'm going to go ahead and put a USB cable in there. Because that'll kind of hold it in place until I can say that. Kind of hold it in place until I can get the screws figured out for that. Sorry. So the box fits really well. And your mileage may vary. Every printer is a little bit different. But when the board is laying right, that reset button will be pushed through there. Pop that back open for just a second. These, and I don't know if I'm going to necessarily use these because I don't want the reset button to be that easy to hit. But this particular pack of buttons came with taps for the end of this. And I didn't try it to see if it would fit. Survey says it does not. It actually locks out the reset button, which isn't so bad, but it's going to help hold the board for right now. So I'm going to go for it. I like it. And I'm not going to put the screws back in the box yet because if it's wrong. But so that's it, and then it's further testing. I'll show you the code next, and show you the changes that was made in the code, and then yeah, I think that's it. I think that once you check out all the information down in the description and check out the code, I think you'll be ready to build one. Or any other project that you want to build. I hope this, at least encourages you to come up with an idea and follow through with it. So, all right, let me get the code together and I'll show you that next. All right, everybody. First and foremost, I want to apologize for the droning noise in the background. That is one of my 3D printers running. And if it's really bad, you'll never even hear this segment because I will end up recutting it, but so hopefully it won't be too bad. But we're going to start right there on line 1. Now these Pro Micros are great little programmable boards, based around the whole Arduino architecture. And what's really cool about these Pro Micros is they support the keyboard library directly without any additional hardware. All right, so that very first line there is actually loading the keyboard library, and which is the cool part about all this. That's what makes this project work so well. Going down to the line 4 and 5 here, those that's just for debouncing the buttons, so that when you hit a certain switch, it doesn't cause that function to happen more than once. Don't modify these, leave them alone, leave them where they are. Then we go down here to line 8, which when I originally wrote this, you were going to be able to add and remove pins as you needed, but we have now consumed up all the pins. You can remove them out of there if you want, if there's pins that you're not using, but really there's no reason unless you're making changes to it, but otherwise you don't even have to worry about changing that. This is pretty critical as far as what you're doing. Now this 10 right here does not include the rotary switch. This is strictly for the push buttons. So I have mine still set to 10. Even though there is capability for 12 buttons, I'm not using the additional 2, so I've left 10. All that's for is there is a for each loop later on that's going to use that key count. In fact, if you look down a little ways there, down around was it 33, it starts to use that. So it just saves a bunch of lines of code by using a for each loop instead of having to write the same little function for every button or every button possibility. Last key and key delay is not to be modified. That's part of the mute on and off and the record on and off capability. I mean, it would work elsewhere too, but it's for a button that you may need to push twice in a row, but you don't want it to bounce. It's technically part of the debounce code. All right, so then we're going to go down here to 17, and this is the input for the rotary switch that allows you to set this bad boy up for 4 different keyboards. And it is using the analog, the A0, A1, A2, A3, the analog input. And I do have some ideas. I won't get too deep into it, but I have some ideas because this rotary switch is actually capable of being a 12 position rotary switch. And I think through the use of some resistors and an analog signal, I could actually make this hotbox into a 12 position hotbox, but we'll cover that sometime later. If that's something that intrigues you, reach out to me, on a private level, email, Twitter, whatever, and we can chat about that. And then this is where the meat starts for the rotary switch as far as configuring what each of those inputs do. This little loop right here is what listens out, and you don't have to modify any of this stuff. I'll show you where you're going to make your modifications, but this right here is just it listening for buttons and making sure that things aren't bouncing. This right here double checks your button push to make sure that you actually did press a button, that it's not a false alarm, and that it's a different button that you've pressed, so that you're not again not bouncing. It's a lot of debounce protection, but it saved my sanity because I was running into some weird issues. So, and I think it's the buttons that I used, but. So this is where the meat of it all starts. This is where you actually get to choose what your buttons do. You'll see that this section is called Do Action 1, and then you scroll down. There's a Do Action 2. Scroll down, Do Action 3. Scroll down and Do Action 4. Now, right now you see 4 has just got, or it's going to just throw up position 4 button 5, position 4 button 4. 3 is the same way. 2 puts in a bunch of URLs, and 1 is actually the way that I have it set up for my OBS. And I'm going to leave this in here, even though you guys may not be using this for OBS. But the reason that I'm going to leave this in is because it actually shows multiple keyboard presses. So this happens to be the command for Alt, and I will try to find a reference to these and put it in the description, but if I don't, you can Google it. You'll find it pretty easily. So the 0x82 is your alternate key, and then Q. So my alternate Q is what starts and stops my recording. And then alternate, I don't even know what that little tick is called. I guess it's just a tick, but that's what mutes and unmutes my mic. And then alternate 1, alternate 2, alternate 3. Those are my buttons, 1, 2, 3, 4, 5, 6, 7, 8, that change my camera angle. So, and again, this is position 1 on the rotary switch. When you go to position 2 on the rotary switch, it's going to, when you hit the first button, it's going to type out www.funking3d.com. Now I could have put a code in there, one of the keyboard presses for the enter key, and that would have allowed me to have it enter the URL and hit enter. But then you end up bumping buttons and weird stuff happens. So that's why that code's not in there. But these are where you're going to edit it. And again, these are print lines, line prints. And the other ones are keyboard presses, mimicking button, mimicking typing. So, and you can, I have a code here. I can't remember honestly what that 176 was, but you can see here I kind of combined two things together, and you can do that. You can have lines with button presses, or whatever you need in between there. So, and that's going to get you there, and that's it. That's the whole thing. That's the whole chunk of code. There's probably ways to make it smaller and clean it up, but this works for me. I like this. Open to suggestions. If you see something that you think could be better or more optimized, or a feature that could be added, absolutely let me know. And again, when you download the files for this, you will get a copy of this code. So that's that, and I will take you to the next section of the video. All right, so I hope you enjoyed that assembly video, mainly the high-speed parts, right? So anyway, overall, I'm pretty pleased with this guy. It has come in very handy. The biggest difference with version 3 is the fact that we added this selector switch right here, which actually gives you 4 positions.
4?
4. It's like 4 in 1. But wait, there's more. Call right now.
Oh.
This switch is actually capable of doing 12 positions. Unfortunately, there's not enough inputs on the Arduino Micro that we're using in there, the Micro Pro. There are ways that it could have been done. I could have developed the circuit a little bit different. I was trying to keep it fairly easy. I think that it did turn out to be pretty easy. There are going to be a link to the files. There will be a link to the files in the description, so you can get the board schematic. I think that there's a PNG file so that you can just print if you want to make the board exactly like I did. The STLs for the box are still iffy. Maybe you download it and the STLs are in there for the hot box. Maybe they're not. I don't know why I'm hesitant on that. Maybe because I think that when you print it, it's not going to be right, but that's probably not true. It'll probably be great. The fit and finish on this box is absolutely perfect. Very pleased with it. It allows us to change that camera angle so very, very quickly. And I don't even really have to look at it, but for a quick second to see what I'm hitting. As you can see, I cut some vinyl stickers for the numbers, my mute button. I can push. And then when I push it, I'm back and you can hear me. So it overall, it's a good project. I right now have the first position set up for OBS. I have the second position set up for Rhinoceros 3D, which is a 3D NURBS modeling program, which is what I use to design all my stuff. I'm actually thinking about changing it so position 1 and 2 are both OBS, so we can have more camera, because we have weird stuff like this, which is our overhead, the detail, and of course, you know, us. But I would like to have one overhead and then, you know, me up here and detail up here. So, but there's only 8 buttons. Now, this particular setup does have the capability of having 2 more inputs, but I set those up specifically so that I could have plugs on the side, so I could go to maybe a foot switch or some other means of input, so that I could switch to a certain camera view without having to move my hands. Just in case I glue myself down to the workplace.
Why would you do that?
Well, it would be an accident. I wouldn't do it on purpose.
Mm-hmm.
So, accidents never happen around here. So, overall, the box is great. There may be a version 4. If it is, it's going to be much smaller than this. I'm actually looking at keyboard size micro switches, which would allow me to do it just in a straight line. Would be very, very easy to set it up. We're also possibly thinking about a sound effects board using kind of the same platform. So maybe there'll be a part 4 or a version 4. Maybe it stays version 3. I like it. I will admit it does cause some issues if you are a 3D printer, because it is an Arduino type board that is plugged into your computer all the time. And sometimes when you go to update that, if you have one of your slicing programs open, the slicing program has grabbed hold of that Arduino thinking it's your 3D printer. Yeah, if you don't understand what I'm talking about, just don't even worry about it. If you're kind of on that level, you'll understand why. So there are times that I have to unplug it to do other things, but it's no big deal. USB in out, it's happy. And it's been really cool for in Rhinoceros, because some of the things that don't have buttons to click, that you'd have to dig through a menu, or maybe they don't have menu options at all and you have to type the shortcuts, I can now just have one. So I can get to, you know, all the booleans just by one touch. It's also really great if you use cheats in a game and you have to type that cheat every time. You can just set up a button for it and just be like, you know, cheat. Don't cheat in games. That's not good. Cheating is not fair. So overall, happy with it. Hope you guys look into building one if you have a use for it. Don't build it if you don't have a use for it. If you do build one, please reach out to us and let us know. If you've made a variation of it, which is great, let us know that too. If you have questions, if you want to collaborate a little bit on it, reach out to me. If I got some time, we'll definitely work that out. Other than that, I think it's it. You got to watch it being built this time. You got to see it. We've been using it in almost every video that we've made, other than the very, very early ones. It became a necessity right away, which is why we made the videos about it. So other than that, I don't think I have anything to say. If I forgot anything, I'll go back and clip it in here and make it look like movie magic, like I said it the first time. And I hope you like it. If you like what we're doing, hit that subscribe button and ring the bell to get notifications. Give us a thumbs up. If you don't like what we're doing, give us a thumbs down. That'll be fine. But also leave us a comment and tell us what we're doing different, or if what we're doing wrong and what we can do different.
You gotta click one.
This one. If you don't like what we're doing and you want to leave us a nasty comment, that's not very nice, but you should probably just, you know, move on. Don't leave us nasty comments. We can handle it. Whatever.
Don't be a troll.
There's always trolls on the internet. And from me and Xander and the hot box, as always, print on.